Alright, so in this video we're going to kind of go off the slides provided by Project Lead the Way to go ahead and talk about flowcharts. And flowcharts are kind of a visual tool that we can use to explain the way that we want our programs to work. And basically that's kind of what we're saying. Flowcharts are commonly based on kind of a similar schematic to express the way that we go through the thinking process. And while we're focusing on how it's used for programming, there are a lot of cases where it's used for condensing down information. So this is a great complement to what we can do with pseudocode. So in this case, we're seeing what are the instructions for how to provide food for a dog. So we start, we check the dog bowl for food. If it's empty, we can put more food in it. If it's not empty, we can go ahead and stop, and we checked and they're good to go. Now, understanding this, we need to kind of have an idea of what the different schematics represent. And in flowcharts, there are lots of possible schematics and symbols that can be used. Programming in particular uses a lot of these. And this is going to get, if you take a programming course, a dedicated class for programming, you'll get a better understanding of what all of these mean. But we're going to focus on 5 simple schematic symbols, the ones I'm most commonly used, and the arrows that we use to go ahead and direct the way that we're thinking about these flowcharts. So, getting us started. Okay, there is a oval symbol that is used as our start and stop command. Okay, the start and the end. Looks like a rectangle. Sometimes you may see it as a bit more of a circular form, but that oval shape goes ahead and indicates this is where you're going to start the program. Think of it almost like the header that we use when we're programming to define what type of program we're using and maybe leave some comments at the beginning, but we simply say this is where we start. And if we end, and not all programs are going to end, we would go ahead and kind of use this as the stop sign. Probably the most used, at least in the scope of what we're doing, are the process symbols. So the idea is it's a rectangle, and it's indicating that the program is going to be doing some sort of action. It could be giving it a mathematical command like addition or subtraction. We could be indicating that we're using a function of the program, like turning on a motor or a light, or indicating that we need to start an LED lighting up. We could also use it to go ahead and give some rotate commands. And generally, these are the short kind of action statements that we're going to make. Then we need to consider the inputs and the outputs of this program. And this is where if a individual is going to be providing some sort of external command, okay, whether it's hitting a key on a keyboard or if it's pressing a switch on a circuit, it's something that's requiring that manual operation by the user. So it could be asking a question like what is your weight, or if it's a circuit with a sensor, is it balanced? It could also consider kind of a timing action. You may have like a clock involved. That information can then kind of feed into the decision that the computer needs to make. And this is where we consider the if-else statements or the for statements, where there's something that the computer needs to identify. Okay? So in this case, we're using a rhombus, kind of a diamond shape, to go indicate that there's some sort of result that's going to come from that checkpoint. And best case designs, the best designs, will make it as a yes or no, true or false type statement. There are some occasions where you may have more than that, but think about keeping it as a simple question. Is this number greater than 10? Does the weight meet the specification? Has your count been reached? Has that switch been pressed? Okay. And that decision can branch out. Okay. So while many of the segments that we've talked about so far, the process, your input and output, those are things that usually only have one result. The decision is where you start thinking, yes, this happened, or no, it didn't. And this is where those arrows help us direct your way of thinking. So the arrows are going to indicate the flow of the chart. Generally, you're going to only go in one direction. Now, once you hit a process, you're going to carry through. It's kind of like the series circuits that we've talked about. Or we can think about, in the case of those decisions, if it's true, we go this way. If it's false, we go that way. Okay. Generally, we do have the arrowhead on there. Usually, the arrowhead is on the resulting spot. But you may have multiple arrows going into the same position. Okay. And I didn't think to include it in this, but think about the way that the Project Lead the Way, our engineering design process works. We've got possibilities to go back to any number of different results based on the result of the current stage that we're operating on. So, other examples of flowcharts, and like I said, I kind of regret not having the Project Lead the Way one, but it could be something as simple as counting from 1 to 9 by odd numbers. Now, before we attempt to draw it, we do want to think about, what are you going to want the output to be, what information is going to be included. You're always having to think about how this program is going to work before you start drawing it out. And this is why often I see some pseudocode happening before you do the flowcharts. Okay? So, the first block should always be that start block. Okay? This is where the program begins. We're making it a case. Okay? But then we need to consider what our outputs can be. We know that we're going to have it at different points showing 1, 3, 5, 7, 9. Okay? But for us to get there, we need to have that starting number. Okay? And this is where we ask for a user input. Okay? The user input, you can type in anything, and because we're dealing with single-digit numbers, we would only ask for or accept a single-digit number. With that in place, okay, we then go ahead and make a statement. Okay? Now, let's see. Now, this is kind of simplifying this down. We're not actually verifying our data, checking through it. So we have the computer go ahead and say, here's the number that I'm giving, and then we add 2. Okay? Again, we're counting by odd numbers. We want to skip the evens. The easiest way of doing that, of course, is adding 2. Now, there are obviously some potential problems with this program, but it's still a simple enough one to go ahead and proceed with. So from here, okay, we've inputted a number. We have assumed it's good. The computer has stated as much. It adds 2. Now we need to check and see, have we reached a number greater than 9? Okay. So we're taking the data, and the process at that add 2 is basically saying, the x variable equals our input number plus 2. This is where you'd actually start getting into like the code side. So we ask if the number is greater than 9, and if it's not, we go back, we state the number, and we add 2, we're able to check again. Okay? But if it is greater than 9, we know that it's time for that program to end. Okay? So we go ahead and put in that end block, and this gives us a map, okay? Basically a roadmap, to writing the program that we actually need to write, whether it's the drag and drop block coding that we've been using with Tinkercad, or if it's something where you're actually writing out the text code. Now, we're not necessarily going to use that example, but in the next video, I will be showing you how you can draw these flowcharts within Google Drawings. I think that's one of the better free software options for creating a flowchart. But I know that in my own experiences, there's many, many different programs out there. Microsoft Visio, OmniGraffle, there are many different pieces of software that can give you a better aesthetic, a better feel for the approaches, or of course the more artistic. But like I said, Google Drawing is a great way of starting, And I think these simplified flowcharts can certainly help you think about the program maybe a little bit better than focusing on the pseudocode, or of course trying to jump straight into the code and seeing what results. So if you have questions, of course, leave comments, send me messages. I'm happy to help you where I can, and I look forward to seeing you in the future.